Hello everyone in the RBMK community. It was a long break now. I decided to come back to make a tutorial video. In this case, it will be an unsafe startup procedure. And you would say, what's the point of doing an unsafe startup? Well, that's the point of a simulator. We will not do this in a real reactor for sure. So, in this case, I will try to start up and bring up the reactor to power as quickly as possible, but not following by any means the book or the security procedures. And I will try not to blow things up. So I will start the RX model. In this tutorial I will also use cheat engine with a new cheat for the fuel consumption, so people can have a look at this also. So what I will do in this unsafe procedure, usually we'll need to starting systems from the, let's say, farther from the reactor. So start by the condensate system, feedwater, condenser circulating water pumps. If we look at the diagram, it will be more clear. So here we have the reactor, primary circuit, drums, feedwater pumps, condenser, etc. So in a normal process we will start from here, from the farther from the reactor, starting pumps and systems, and once we reach the reactor and the loop 1 and loop 2 are pumping water through the reactor, then we will start pulling rods. Now I will do exactly the contrary. I will start pulling rods immediately now to speed up the process, which is totally forbidden, and then I will go from reactor farther. So I will start turning on pumps starting in the loop 1 and loop 2, go to the feedwater pumps, condensate system, and finally these two, how are they called, the condenser circulating water pumps. So let's start. I will open the reactor absorber rod control, and I will not use the central core only, which is just a safety procedure. I will switch to fast and pull rods in all the grid. So we see the neutron rate immediately increasing here. At the same time I will switch off the offline cooling systems, so we start heating up the water in the primary, and I will also close the outlet valve in the loop 1 and loop 2. I will connect the diesel systems for the emergency cooling. And now we will need to keep an eye into the neutron rate, not to get too high. We get an alarm at 8%, but maybe we can get a bit higher, 10 or 15, but not more than that. Okay, now that we did that, we'll start the loop 1 and loop 2. It's very dangerous to have activity in the reactor without having flow of water, because if we start boiling water, this is a positive void coefficient reactor, so the thing can get exponential very quickly and blow up. So let's turn on the pump 1 in each one of the loops. First open the inlet valve. Once it's at 100%, we turn on the pump, and once the pump is on, pump 1 and 2, we open the outlet valve. This is to avoid cavitation, this procedure. I mean, why we do this, first the inlet, then the pump, then the outlet, is to avoid cavitation. Okay, they are at 100%, so we have flow in the primary. We were just a few seconds without flow. It's the time in between switching off the offline core and switching on the loop 1 and loop 2 pumping. Okay, now we see the neutron rate going higher and higher. We'll reduce the velocity to medium, and I will continue going back in the system. Now let's go to the feedwater pumps. The same, one pump, turn on the pump, and when it's on, the discharge valve. And the neutron rate is going very high now. I will go to slow, and it's still too high, so I will hold it. And meanwhile I come back to the feedwater pumps and systems, and open the discharge valve. So we have one of the 3 pumps in the feedwater pump and systems on. That's fine. And we see the neutron rate going very low now. We pull rods again, but now we need to be careful because it increases very fast. So once it reaches like 10%, we hold again. Hold. Okay. And now maybe the most important will be the water treatment pumps, so we can continue increasing power in the reactor without getting too low reactor level. Okay, we can also start the condensate, even if it's not critical at this point. Condensate system, turn on one of the 3 pumps, the aerator level into auto, and the 2 polishers. Okay, and meanwhile we will pull a bit more rods, keeping an eye into the neutron rate here. And hold. Now I will already open the reactor power regulation, which controls automatically the reactor power, because we are already at neutron flux of 1%, so I will reduce here neutron flux. Okay, we're at 2%, so we will increase back 2%, and when this engages we don't need to pull rods manually anymore. We're at 3%, so it didn't engage. Now we see this spike here. Probably the system engaged now. We're at 4%. No, we didn't. Okay, because it's not on. I need to click here, on. And we see the neutron rate going negative. It's because it engaged to 2%. So now I will increase to 5%. Probably it doesn't let me because there are some alarms that block it for the moment. I will turn on the turbine. Probably it's the turbine which needs to be reset to allow for automatic control. So turbine support systems, lubricating oil, and we wait for this number to stabilize. Hydraulic systems for the controlling valves. And it seems to reach, yeah, 11,000. Steam drain, and we do not start the steam seal yet. First we need to reset the turbine. When this LED lights up, we switch on the turning gear, and we see the speed set point increasing now when it reaches 20 RPMs, which is the turning gear. It's an electric motor that spins the turbine mechanically to be ready to start taking steam. Okay, it's at 20, so now we can start the steam seal, and at this point the turbine could already be turned with steam from the primary system. So I will close this window, and now it seems that we can already increase power set point in the reactor. I will go to 5% and wait a bit, and then we'll go to 10%. We see the red warning here, reactor protection bypass, so I will switch on the auto scram control, and this disappears. And neutron flux at 0%. Okay, so I need to pull rods manually because while I was with the turbine, the neutron flux dropped too much. So now the reactor is almost stalled. I need to pull rods again. I will hold. We're at neutron rate of 13%. And we have scram. Wow, that's really bad news. Because I engaged the auto scram control and I went past 10% or so, we got reactor scram. And we have a really low activity now. We totally stalled the reactor. I will switch off the auto scram control. That's my bad. Okay, pull rods. I don't think it will allow me because there is this, because there is the alarm here. The reactor scram is reset. Turbine is reset. Can I pull rods? Fast. Yes, I'm pulling rods now. So if we were in the BW reactor simulator now, the one from Acme, now we can say we're in the source range, really low neutron activity, here at -40 in a logarithmic scale. So now I will not look too much at the neutron rate. Even if I get higher than 10, I will not worry, because I have auto scram control disconnected, and I just want to get this around 0, and then I will be more careful. So I'm just pulling rods in a fast mode, and this was not expected, but okay, this happens. Sometimes you trigger scrams. Okay, while waiting I will continue starting other systems. The aerator steam supply, set the aerator steam level or pressure into auto, pressure set point at 98, and I will open the vent valve at around 50%. I'm not yet opening cheat engine, because my purpose here was to bring the reactor up to power as quickly as possible and then go to cheat engine. But now the xenon concentration is increasing, so we should not forget about this. Okay, this is around 45, that's fine. Neutron rate at 5%, and the activity is at -5, exponent -5. So let's go to medium. Neutron rate 7%, and let's go to slow. Neutron rate 10%, and we're getting to positive exponent in the neutron activity. 13%. I will wait up to 20 and then hold. Okay, hold. 20% of neutron rate is totally unsafe, but because I bypass the auto scram control, I can do this for the moment. And we have a neutron flux 1%, so I will try to engage the automatic reactor control. Yes, it seems to be engaged. You see the drop here in neutron rate, and now I can increase to 5%. Very good, and now I can engage the auto scram control without creating a scram. We see the alarm disappearing, the warning of bypass, and everything looks fine, so I will increase power set point to 10%. Now it's at 10%, and now I will open some schematics, the core to see temperatures and flow, turbine, steam drum, the aerator, and feedwater system. I think there is something missing in the procedure. I didn't switch on the condenser air ejector. Now it's on. It will light up when the vacuum pressure is enough. And I should open or increase the set point of the main steam dam control. Otherwise we will create a disk drum disk breccia or trouble. Let's set it at 7500. That's fine. And now normally we should wait until we get enough high pressure in the drum of around 7500 and then start spinning up the turbine. But just to speed up things a bit, I will increase power set point to 15%. Okay, now it's 15%, so reactor is generating more heat, we are heating water faster, so we are creating pressure, we are increasing pressure faster in the drum. We should be careful with this because normally we will not connect the second feedwater pump until the turbine is connected. But this is a normal procedure in which we don't surpass 10% of power set point or 15% until we connect the turbine. But now, because we're speeding up the procedure, probably I will turn on the second pump so we don't have shortage of water in the reactor. It can happen if like I increase a bit more now the power set point, like 20%, just to boil water faster. It reaches a point in we boil so much water that one of the 3 feedwater pumps cannot catch up with the steam flow, and it cannot restore the level of the drum and the reactor. So if the level gets too low, we will damage some channels in the reactor. So now I will switch on the second pump and I will open the discharge valve. And theoretically, this should allow us to go a bit further in reactor power. Let's set it to 20. And at the same time, we see the aerator increasing pressure. Sorry, the condenser vacuum is increasing pressure. We also get at the same time the high pressure in the aerator here, 238. And I will increase reactor to 20. Okay. And the drum is at 1500 now. I will just have a look into the plant overview schematic and everything looks fine. The 2 pumps here, I just connected the second feedwater pump, even if this is not by the book, just to cope with this 20% of reactor power. Condensate pumps, there is only 1 out of 3, because at the moment we don't have flow going through the condenser yet. But just to anticipate, I will connect the second one. Okay, it's on. Where is it? The drum pressure is at 4000. And I don't know why I cannot open the schematic. I don't like that. Strange. Okay, anyway. Okay, and we're approaching the 7500 pressure we need, so I will start reducing power set point to 15%. And I will start opening the valve in the turbine. If we do things by the book, we need to open this when we reach 7500 of pressure in the drum. I start before just to save time. I will open to 10% and now decrease power set point to 10. I will open a bit more to 14%, the startup valve of the turbine, and we see the speed of the turbine spinning up at 1800 RPMs. We need to reach 3600 and then synchronize the turbine to the grid. We see the reactor level going very low now. This is because at the same time we decrease a lot the power set point, so we decrease the voiding, and the main steam dam control valve open, so this increases a lot the steam flow, and that's why it takes some time to cope with this. If we reach a really low value like this part of the trend chart, then we really have danger of damaging the channels. Speed of the turbine at 2800. I will start closing the valve after 3000. I will close to 10%. And I know that we need around 4.5% of opening of the startup valve at this drum pressure to keep the turbine at 3600 RPMs. So let's anticipate for this and start closing. So we end up at this nominal speed at the correct opening. We're at 200 RPMs of the nominal, and I will just start the oscilloscope now. Now it's rotating like crazy because we are far from nominal. So once we reach nominal, we need to stabilize as close as possible to 3600, then increase the power set point to a higher value like 9 or 10,000, so we are sure that we have an increasing pressure rate, so we don't have a negative or reverse polarity in the generator. Okay, we are getting closer to nominal velocity, so I'm just around 1% of opening above what we need for the nominal. So we see the increase of speed is slower and slower. Now it's increasing just 2 RPMs per second, more or less. When we reach to 3590, I will decrease 1 point more, so 0.5%. We're at 4.5% now, and I will close. No, I cannot close now yet. I need to increase. Okay, now I will close at the top dead center. Perfect. Now we are on grid. The generated load is 0.1 megawatts, and we need to increase power set point now to 15%. 15%. The main steam dam control closed the valve, so now we have an increasing pressure in the drum, and this should make the generated load increase. I will manually open more the valve now. Perfect. I was expecting the generated load to increase, but actually this only happens if you are in auto. So if the turbine keeps a constant pressure and you are in auto setting, when the excess heat of the reactor increases pressure, the turbine will automatically open the valve. I was in manual, so I needed to open manually the valve to increase generated load. So now we are at 1 megawatt. We don't have any more danger of reverse polarity. And now I will switch to auto. Switching to auto will automatically open drastically more the startup valve, and you see the generated load increasing much more now. We're at a power set point of 8600. We don't need that much, so I will manually decrease to 7500. And when I press enter, you will see the generated load increasing a lot, because we have now some excess pressure that we can turn it into energy. So 33 megawatts. Now we are far enough from zero. I think we can safely switch into main valve, and we see main valve opening while startup closing, generated load increasing to 80 megawatts or so. Okay, so everything looks fine. We are on grid. I will increase power a bit more to 20, and I will connect the third pump, the third feedwater pump. In a normal processor, you connect one pump, you don't surpass 15% of power until this point, and then you connect the 3 pumps. We connected the second one because we wanted to hit a bit faster the drum, just in case we were getting too low reactor level. Switch on the second pump. Open the discharge valve, and now we can switch to 3-element control and to main valve. Momentaneously, probably the generated load will decrease because we're injecting some cool water into the system, I think. But this is, you see here in the trend, generated load when we connected the 3-element control just went down a bit. So you always need to make sure you are around or above 50 or 70 megawatts before you connect the 3-element control. Okay, we can close the feedwater pumps and systems. In the condenser system, we already switched on the second pump, so we are fine with this. We can go into the turbine support systems and close the steam drain. This will probably increase a bit the generated load because we don't waste steam now. And now we can keep increasing power set point to 25%. Past 25, we will need to start the second pump in the loop 1 and loop 2 in the primary. But this is by the book, but if we look at the voiding, it's just 6%. While we don't surpass like 17 or 20%, we don't really need to do so. So we can continue increasing power set point to, let's say, 35%. And now it's the moment to take care of the turbine, because when we start increasing power very fast, we will hit the rotor much faster than the shell. We see here the rotor at 204 degrees, the shell at 187. This creates differential expansion. We have a differential expansion of 0.059. I guess this is in meters, so this is 62 millimeters, probably, I don't know. And we see this here graphically. We have these 2 red lines in the left and to the left and to the right. To the right will be when the rotor is more hot than the shell, to the left the contrary. So when we reach this red line, we will be in trouble. We'll create a lot of vibration. For the moment it's still fine, so we can keep increasing power set point. And now we have a voiding of 10%, so let's keep an eye on this. Probably I will go to 60% of power set point and then turn on the second pump. Okay, we're at 60% now. And the xenon is very high, it's at 164. The remaining foil is at 96%. So I will connect the second pump and probably I will go to cheat engine in a moment. We open the inlet valve, and at the same time we can just turn on the third one, so we will not need to do later to go to 100% power. We turn on the pumps 2 and 3 of the loops 1 and 2. And open the outlet valves. Okay, we're done with the loop 1 and loop 2 recirculation pumps. We can increase a bit more power set point. Let's go to 75. Voiding is at 9% after turning on all the pumps. We're at 76.5% power set point. And now it's a good moment to go to cheat. Sorry, I just hit the microphone. Now it's a good moment to go to cheat engine. We open the process Chernobyl RBMK reactor 3. Load the associated table. No, because this one is only for xenon. So I will open the one that I prepare for xenon plus fuel consumption. You can check my previous video about this fix, in which I found the memory addresses for the fuel consumption. If you don't use cheat engine for fuel consumption, the fuel will be consumed in around 1 or 2 hours after being at nominal power. So you cannot run the simulator for a very long time. So I found the memory addresses for the 25 channels, and what we'll do here is to fix them, selecting these boxes, and this will keep the memory address at the value of the moment I hit these boxes. So now fuel is not being consumed anymore. We can run this reactor concerning fuel consumption indefinitely. For the xenon, I will not select it because now we're at a fairly high power. So now xenon is already being consumed or decreased by neutron activity. So we don't need to use this box here. This memory addresses was found by Comrade 3DR. Is the 23210, and these are the memory addresses from 23870 with increase of 4 each to 238D0, 25 addresses in total. I'm still looking for the HEPA filter address using cheat engine. This is the suggestion of user Comrade Ton8346, which in real life he is a control room operator in a chemical plant. So this is very cool that I have some viewers that actually use they are operating real reactors. Thanks for your comment, Comrade Ton8346. He suggested me that the only thing lacking in this simulator to operate this indefinitely in a safe situation is to fix the HEPA filter, which we have here. We see the HEPA filter increasing its usage at 193 now. If we wait a bit, we will see this increasing to 894. And as the same as in fuel consumption, we need to fix this in order to run this simulator indefinitely. I didn't find this fix yet, but I spent several days on it. I think I will end up finding it, so I will publish a video if I do so. So now we are at 700 megawatts. The differential expansion is very low, the vibration is very low, so I think we can already go up to 100% power. I will go to 95% first. Okay, 95. Generated load 889. The main valve is open at 90%, and this is still automatically governed. Now I will try to adjust a bit more the power set point to the actual minimum, so we can have a bit more of power, which is 7355. And we see immediately the power set point increasing, the generated load to 920 megawatts. I will keep increasing power set point of the reactor to get close to 100%. We cannot reach 100% because if the neutron flux reaches 100%, we have a meltdown. So I will go. You see that we have power set point at 99%, but we have neutron flux at 99.1. Why is this? This is because of xenon decrease. If I fix xenon now, we'll see how the power set point matches the neutron flux. I will do just to show you now. Fix the xenon and you see the neutron flux is 0 because now there is no increase nor decrease of reactivity in the reactor. So what we set in the power set point is what it is in neutron flux, because the controller doesn't need to move to adjust it. When I deselect the xenon, because now the xenon concentration is fairly high, it's 156%, So xenon is decreasing, you can see it now. The decimal point is decreasing as we look at it. It means the control rods are being inserted to compensate for this. That's why there is this discrepancy between power set point and neutron flux. If we wait a long enough time and we reach a new thermal power equal to neutron flux and a xenon concentration asymptotic, which doesn't change anymore, I expect to have a power set point which is the same as the neutron flux. For the moment we cannot set the power set point to 100 because this would mean a neutron flux of 100.1%. This is a meltdown of the reactor. So I will increase the last step, which is 99.5, and we get a neutron flux of 99.6. We need to be really careful at this point because any change in void, like turning on suddenly two pumps in the loop 1 and loop 2, could create a meltdown by a sudden increase of neutron flux, or any other like sudden change in the systems could create a meltdown now. We have a generated load of 980 something, and this is oscillating because we are in auto control, so the main valve is opening and closing between 97.7 and 97.3 to keep this pressure set point. Now what we need to do is to wait until the thermal power goes higher by the fission products of uranium, and we can get to a higher generated load, which can be more than 1000. I don't know exactly, 1020, 1030, maybe even 1040. For the moment I will end up this tutorial here. This was an unsafe startup of the reactor. I created a scram by mistake, so this probably made the procedure 5 minutes slower. We're at 37 minutes now, and also because I was talking and showing things during the video, so we could say this unsafe startup took half an hour without the scram mistake. But you can really do, if you don't lose time talking or showing things, you could do this in 12 minutes probably in a really unsafe startup procedure. I will switch on to manual control in the reactor. So I just look what are the maximum minimum values, which are 97.9, 97.5, and set something in between. We see the pressure point increasing here, so I can increase a bit to 98, and now it's slightly decreasing. So we are almost at 100% of opening of the main valve. Of course we cannot get nominal power until this valve is at 100%, but we cannot open this valve at 100% until we don't get enough pressure. So we will need to wait for this thermal power increase a bit. From my experience, I think around 95.5% of thermal power, we can already open the main valve at 100% without going below 33.55 of pressure. So the thing to do here is just wait for this to increase, and when we are like around 7400, we open a bit more the valve, and so on until we reach 100%. We're almost at 1000 megawatts, but I cannot wait, otherwise the video will be too long. All the other systems are fine. Probably I can decrease a bit the pressure in the aerator to increase a bit power to 48. Yes, this is increasing power a bit. I can also close the aerator vent valve. Not sure that the aerator has some effect at this point, because I'm not sure we are venting. Yes, we're venting. I see here the value, and I'm decreasing it, so probably decreasing the aerator vent opening will slightly increase the generated load. I cannot go below 48 in the pressure power set point in the aerator. I will leave it at 5%. And now we got a fairly high pressure in the drum, so I can open a bit more the valve. 98.5, and we're almost at 1000. I would like to reach 1000 before finishing the video if possible. So I will just open a bit more. For sure we'll get to low pressure in the drum, but just to get to 1000. 996 almost. I will open a bit more. We're at just 5.5% of 100%, and we didn't reach, but I will open a bit more. We're at 100% opening of the main valve, and we're at 1000 megawatts. Now it decreased back to 999 because we're at a really low power, so I will close back a bit the valve to avoid a too low pressure in the drum. Okay, so that was it for this Unsafe startup video. I hope you enjoyed it. See you in the next video. Bye.